So in this next lesson we're going to look at how we can graph the behavior of polynomials, and we're going to use the concept of the real zeros to see how it behaves and how to sketch out a graph of a polynomial. So let's just start by looking at an example of a polynomial that has this sort of graph, and you can note here we have a 0 right here and another 0 right here. Where it crosses the x-axis, we have what we call our zeros. We also can figure out the factors from this. We can also say that these are the solution points for when f of x, this function here, is equal to 0, because along this x-axis, the y value here is 0. Any point along here is 0, and this is where f of x is equal to 0. So we note in one case, we have a case here where the 0 crosses, where the function crosses through the 0, but in the other case over here, we see that the function is just merely tangent. It doesn't cross through the x-axis. In the case where the function crosses through the x-axis, the factor, the x minus k factor, will be odd. So this would be, for example, x minus 3 to the first power, or x minus 3 to, say, the fifth power, for example, where this is, the 3, and we have our factor x minus 3 because of that. But when it's raised to an odd power, we know the polynomial function will cross through that 0. Whereas in the case where the 0, or the function is tangent to the 0, the factor, the x minus k factor, is raised to an even power. So in this example here, say this is at -2. The factor is x plus 2, and in this case it's raised to an even power, like 2 or 10 or 4 or anything like that. So let's see how we can apply this to sketching out a function, a polynomial function. Suppose we have this polynomial function all factored out for us. First thing to do, we plot the zeros. We have a 0 at 3, we have a 0 at -5, we have another 0 at -1. Now let's look at the end behavior. To do this, we're going to figure out what the degree of this polynomial is, and we're going to add up basically the exponents of each of these. We have x to the second power, that's 2, x to the first power, so that's 2 plus 1 is 3, and then x to the fourth power, that's 7. 2 plus 1 plus 4 is our degree 7. We look at the leading coefficient, and our leading coefficient is positive, so this gives us the end behavior diagrammed like this. So we can sketch that into the graph right here. It's going to go down here and up here. How it behaves through here, we're going to figure out right now. Now the first one over here, let's start from the left. This one is caused by this factor raised to the first power. This is odd, so it's going to cross through. So we'll label that as crossing, and we can actually sketch that in. Let's look at the next 0. This one is from this factor here, raised to the fourth power, even, so it's tangent to the x-axis. It's going to come down and come back up. It's not going to cross through the axis. Now this next one we can actually figure out even without doing anything. It must loop back up because we know the end behavior is up here. We know it, if it were to cross through, it'd have to cross through again to get up here, but we know that there's not any additional zeros. So we know it must be tangent, but let's just look at it again. X minus 3 raised to the second power is even, it's tangent. So then we can sketch out the final part here. Let's look at one more, just for another example. So here's another example of a polynomial. Let's plot out the zeros. We have one at 5, one at -4, and another one at 3. Let's look at the end behavior now. In this case, we add up the exponents. 1 plus 2 plus 1 is 4. The degree is 4. We have a negative leading coefficient, so we mark it negative. And we know based on this that the behavior is going to look like this, down, down. So we'll sketch that into the graph. We'll put the end behavior here on either side of the zeros. Now let's figure out what's happening at each of the zeros. This 0 here is from this factor here, raised to the second power. It's even, so it's tangent. The next one, next 0, is from this factor raised to the odd power. This is a 1, so it's going to be crossing. Last one must cross through just because it has to go through this to get down to this end behavior arrow down here, but let's just double check. X to the 5th raised to the first power crosses through. Odd power crosses. So this is our sketch, and it's just a sketch. We actually don't know exactly how deeply this went down and went back up, or how high this went and came back down. But this is a really nice rough sketch of this polynomial, and that's the goal of this lesson right here.